Okay, so today we are going to learn how to find the vertex of a parabola and then graph the parabola. Of course, this wouldn't be very fun unless I could start by talking about a nice little dog. Very nice story. And the purpose of this story is it'll kind of possibly help us remember the characteristics of a parabola. There are 5 characteristics we actually need to understand. So here I've got this nice little dog, and there's the house where its owner lives, and there's a set of train tracks. And of course, the dog likes to bark at the train if the train goes by, but the dog also likes to eat dog food in case the owner puts dog food out by the front porch. Right? And of course, the dog never knows when a train might go by, and the dog never quite knows when the owner might put a bowl of food out. So if the dog decides to start wandering around, the dog is also going to wander around in a path where it's equally close to the train tracks as it is to the house. Right? So let's watch this doggy wander around. Right? So the dog walks around, and it's always going to be the same distance to the house as it is to the train tracks. And of course, if you know much about a dog, it's going to wear quite a path in the ground. Right? You'll be able to see exactly where the dog's been wandering back and forth. Okay, so what are all these magical locations? Well, the parabola is actually the path worn in the ground by that dog walking around. Right, so that's the actual parabola. The vertex is where we saw the dog in that very first picture, halfway between the house and the train tracks. The focus is where that house was located. The directrix is the name for the train tracks. Notice the focus and the directrix are not actually parts of the parabola. They're just guides that help us graph it correctly. And then if we draw a line, a vertical line that goes through the house and where the dog started, also known as the focus and the vertex, that's our axis of symmetry. That's the mirror, right? A parabola makes a mirror reflection of itself when we cut it in half like this. So more specifically, right, the focus is in the interior of the parabola. It lies on the axis of symmetry. The vertex lies halfway between the focus and the directrix. The directrix is perpendicular to the axis of symmetry. And the marks on that figure are illustrating that for any point on that parabola, you are the same distance to the focus as you are to the directrix. Now, of course, we're used to looking at y equals instead of a function of x equals. And these are pretty interchangeable. So if I ever put f of x equals and then I put an expression, you can almost think of it as, hey, y equals instead of f of x. And for the quadratic formula, part of that quadratic formula actually helps us find the location of the vertex. The x coordinate of the vertex of the parabola is minus b over 2 times a. Right? So if I have an equation and it's written in the correct order, minus b over 2a will find the x coordinate of the vertex. So let's do an example. So we've got a function of x, and it's equal to 3x squared plus 12x plus 4. It's in the correct order, so I can proceed. I know the x coordinate of the vertex is minus b over 2 times a. Notice I've got the minus sign out in front. B was 12, so I put 12 in the numerator. 2 times a becomes 2 times 3 because there's a 3 on the x squared. 2 times 3, of course, is 6. 12 divided by 6 is 2. Notice I kept that negative symbol the whole way through. So the x coordinate of the vertex is negative 2. Now, since I actually want to graph the parabola, I need to make a table. And I want the negative 2 as my middle entry, because that's where the vertex is going to be. And then notice I'm also going to plot 3 points on each side. Of course, if I plug in the negative 2 for x, I can calculate the value of y. And of course, I got to remember my order of operations, right? My purple elephants merrily dance after sunset. Or maybe you learned, please excuse my dear Aunt Sally. Or maybe you just think of it as PEMDAS. Right? So inside the parentheses first, there's nothing that needs to be done. Then I'll look at the exponents. So negative 2 squared becomes a positive 4. Multiply or divide. So I'll do my 3 times 4 is 12. My 12 times negative 2 is negative 24. Then I'll do any adding or subtracting from left to right. And y becomes a negative 8. So my vertex is negative 2, comma, negative 8, right? That's an ordered pair. Now, I'll count by ones with negative 2 in the middle. So on one side of the negative 2, I'll want negative 3, negative 4, negative 5. On the other side of the negative 2, I want negative 1, 0, 1. Just think of a number line. Right? I think, hey, if I'm looking at negative 2 on a number line, which numbers are on each side? And then I just start plugging in these values. I can plug in a negative 1, and I can calculate y to be negative 5. I can plug in 0. That one's pretty easy to calculate. Y would be 4. I can plug in 1, calculate that. Y is 19. Obviously, I didn't show all the step-by-step work for PEMDAS there. Now, the neat thing about the parabola, because of the axis of symmetry, the answers on one side of the vertex can be reused on the other side. So I can reuse the negative 5, I can reuse the 4, and I can reuse the 19. Or if you'd rather, you could plug in the values of x. Now I want to grab a piece of graph paper. Remember, our x-axis goes left and right. The y-axis goes up and down. And I start plotting some points. First one I'll do is the vertex, right? Negative 2, comma, negative 8. So it's got to line up with negative 2 for x. Has to line up with negative 8 for y. And then I can proceed to plot the other points. And then after I get all my points plotted, I want to try to fit them with a curve. Right, so here comes the parabola. Notice that I tried to make it rounded at the vertex, so it looks more like a U and not so much a V. And I also want arrowheads on my parabola to indicate that it goes on forever. All right, so find the x-coordinate of the vertex, calculate the y-coordinate of the vertex, complete a table so you have 3 more points on each side, plot the points, draw a parabola that contains the points, make sure your parabola looks a little bit more rounded like a U and not so much like a V, and then include arrowheads on the ends. Now you'll have an opportunity to practice. If you're successful for the practice, I can provide you with an exit ticket. And if you finish the exit ticket, I'll let you know which IXL you may work on.